This lecture, we will talk about operations and functions of Pandas data structures. So for the arithmetic operations and data alignment, Pandas can align index coming from two different data structures when you are performing an arithmetic operation. For example, two series are defined, but the labels of them are not perfectly matching each other. So if we sum these two series, when the labels are present in both operators, the values will be added, while in the opposite case, they will also be shown in the result, but with the value NaN, not a number. So these two series labels are not perfectly matched. So if we add these together, then for the label black, green, brown, we have the not a number in the result. You can see these three index black, brown, green will have NaN in output. And in the case of the data frame, although it may appear more complex, the alignment follows the same principle, but is carried out both for the rows and for the columns. So for these two data frame, index not exactly the same for the two data frames, and columns also not all the same. So if we sum these together, the result will have many, not a number. For example, for this column, mug and a paper will have not a number. Pencil also. And for the row green, red, all the values have not a number. The flexible arithmetic methods, we call this kind of operations a flexible arithmetic methods. For example, you can add frame 1 with frame 2, get the same results as the previous statement, but now we can use frame 1 dot add parentheses frame 2. We get the same results as frame 1 plus frame 2. And operations between data frame and series. For example, we define these two structures, and the index of series match the names of the columns of the data frame. So series has index ball, pen, pencil, paper, and for the data frame, the columns variable name also ball, pen, pencil, paper. Then if we add these together, we minus frame minus, then the result will be very clear. You can see the elements of the series are subtracted from the values of the data frame corresponding to the same index on the data frame's column. So the value is subtracted for all values of the column regardless of their index. So if we minus a data frame with a series, then the series index will match the columns of data frame, and the value will be minused for each value of each column. If an index is not present in one of the two data structures, the result will be a new column with that index only, that all its elements will be NaN. For example, we add one index for series called mug, and the value is 9. Then if we minus frame and with this series again, then we'll create a new column in the resulting data frame called mug, and the value will all be NaN. And the functions by element. So the Pandas library is built on the foundations of NumPy, and that extends many of its features by adapting them to the new data structures as series and data frame. Among these are the universal function called ufunc, and this class of functions operates by elements in the data structure. So for example, you could calculate the square root of each value in the data frame using numpy's np.square-root. So we can write np.square-root, actually the same form as for the numpy array, but here is data frame. So each value of this data frame will be calculated with the square root in the resulting data frame. And the functions by row or column, using the apply function to apply, for example, and a user define a function by columns or rows of a data frame. So we can define a function maximum value minus the minimum value, then apply this function to the data frame, and this default is by column, so the result will be a series, and the index of the series are column variables in original data frame. So this function is applied for each column of the data frame, and the result will be a series with the index of value is same as the columns of original data frame. And if you want to apply by rows of the data frame, you have to add axis equals 1 in the parentheses of the apply function. So in this case, if we apply for the row, then the result will also be a series, and the index is the series. Index is the row index of the original data frame. And extending the application to many functions simultaneously, then the result will return a data frame. So for example, here we'll define a function, but we return a series, not a single value here. Return a series, and the series inside the series is two values. The first is minimum and the second is maximum, and also two values in the index for this series. Then next, if we apply this function to the data frame, and the result will be a data frame with the index are the two functions defined in this function, and columns are the same as the original data frame. We will show out this statement in Anaconda Spider. See the file called section 11 introducing pandas library.py, and the links to this file can be found in the description of this video. We move to lecture 7, operations, functions, and mapping of pandas data structure. First, import these two libraries, pandas and numpy. Then create two series with not the exactly the same index. Then we add this together. I've seen black, brown, green index have NaN value. And for the data frame, we create two data frame. Frame 1, frame 2, then we add them together. The result will be these two columns, not a number, and these two rows are not a number value. Oh, there's this column also 3 column, not a number. Then for the flexible arithmetic methods, we can add this frame with the add function. The result will be the same. And operations between data frame and a series, we create a data frame, then create a series, then we minus data frame with a series. Then the result will be a data frame with the same column name and same index as the original, but the series has been minused by column. If the series, in this case, the series index are the same as the data frame's column name, so it will have no NaN number here. But if we add a series new index value as 9 and index called mark, then we calculate the minus again. Then comes a new column with NaN number in the resulting data frame, and the functions by element create a data frame. Then we can use numpy's function, square root function, to this data frame, and the result will be the same shape dimension as the original data frame, and all the values, each values has been calculated with the square root function. And functions by row, for example, this is a function. We can define this function in this way. Then apply this function to the data frame. The result will be a series with the index same as the original data frame's column variable. This is by column application. And if we want to apply this function by rows of the data frame, we have to add x is 1, x is 1. So the result will be a series with the index same as the row index of the original data frame. So this function has been applied by rows of the data frame. And we can also define a function which returns a series, and inside the series there are two functions will be applied. Then apply this function to the data frame again. The result will be a data frame with index 2 rows same as the two function defined in this function, and the column will be the same